Okay. Hi, and welcome to our Built with WebRTC event. This time with me are the guys from Digital Samba. And we've got Robert Strobl, CEO and founder of Digital Samba, Conal Mullan, right? Head of Operations, and Petar Minchev, Head of Development.
Hey,
I'm Tzachi, I'm Tzachi Levent-Levy from Blog Geek Me, and I'll be the one asking and grilling the questions here. So I guess first thing I want to talk about and discuss is Digital Samba, as far as I know, is a CPaaS vendor. And for me, in the last year or two, the way I boxed your the way I thought about you was a CPaaS vendor. The deals or focuses on pre-built, which means a ready-made UI that customers can use in order to build their applications, their video applications, and the company that doesn't use like the three big cloud vendors to host their infrastructure. Would that be like the right way to think about that?
Yeah, I think that's a good framing. So we very much focus on pre-built, and we tried to take a European approach, a privacy-first approach, which led us to a few decisions, which I think we'll be discussing today.
Okay. Can you just show what pre-built means?
Sure. So for us, what pre-built means is that we provide a front end to our application.
Mm-hmm.
And maybe just to give a very quick history about us, we've been around since 2003. Like you said, we were kind of what we call the B2C vendor, which was competing with Zoom and Teams. But over the last couple of years, we decided we wanted to make a pivot. And we now serve this pre-built application to companies who want to integrate video conferencing quickly with just a couple of lines of code. So as opposed to some of our competitors, we don't offer individual streams, but rather deliver this whole component, which then has obviously got different scaling considerations and problems that we need to overcome when we serve a full front end to our customers.
Okay. And when you say you don't really use the large IaaS vendors, is that just because of the need to be European, or is there other reasoning behind that?
It's based on legal concerns, which are driven by GDPR and European privacy laws. So you're surely aware of this, but in the US, there's something called the FISA, or Foreign Intelligence Surveillance Act, or the Cloud Act, which allow access to public or personally identifiable information, which Europe is very much against. And the only way for us to do this is by working with purely European players. So it's a privacy concern.
Okay. And that means essentially that you're not using Amazon or Google or Azure.
Correct. None of those players, which I think are the easier choice when you want to build an internet application in many ways, or at least it's the first choice that many people make. And we had to and did find some really great European partners. So we went on a journey, and I think Conal will talk about it a little bit later on. But I don't want to give away too much right now to steal Conal's piece of the show. But yes, that's pretty much it.
I guess we're getting there. What does it take to build today? It's funny because in the past I couldn't even think about doing things in the cloud. Everything was done on premise anyways. And now we're talking about how hard is it to move things from the cloud or from the, let's call it, big cloud vendors to something else? What are the main challenges that you need to deal with when doing that?
From our point of view, on the infrastructure side, that there wasn't, the challenges weren't that hard. Once we'd set the target of wanting to achieve not using these US vendors, we just went looking. There was a bit of work and research done as regards trying to find European-based cloud solutions. We did experiment a bit with LeaseWeb's cloud stack solution, but we realized it wasn't really a good fit. But once we focused on AWS, EC2 like service providers, once we started focusing exactly what we need, it was quite easy to find these European players in the same market. And then once the providers were identified, our engineers, we do have some knowledge within the company of using AWS AWS API. So we adapted and integrated quite quickly. An interesting upside of this little journey was we've actually found that these vendors' pricing is more transparent and more cost effective for us. So it wasn't really a challenge, a wee bit of research work, and yeah.
I guess it also I guess it also meant that you focused on the kind of experiences that you get from EC2 and S3, getting compute, storage, and everything else you need to cobble up on your own. Correct? It's like you're not using functions like AWS Lambda or an equivalent or Redshift database that is managed.
Yeah, we sort of prefer to keep our scale and logic, bespoke. We use our own logic, so that gives us complete control over when a server starts. We know when the server should be starting, and we can sort of troubleshoot it and understand how it should work a bit better. So that gives us control in that aspect. The other aspects of the database, again, back to the privacy side of things, we want there is user data on your database, so we'd rather have complete control over that. And again, it's more cost effective to build out our own solutions using open source projects. Yeah.
Okay. And you gave me this diagram earlier. Can you walk me through that? How does that fit into the different solutions that you have?
Sorry, could you repeat the start of your question?
So you've given me this diagram about the infrastructure that you have.
Yeah.
Can you walk me through it a bit?
Okay, so at the top level, right, we made this choice of European-owned vendors. So we have the physical servers, and LeaseWeb have been great for us. They're a long-term partner of ours, 10, 15 years. They've been reliable, very minimum issues with them, so we would never really no need to change. So, and that's, you can see that our deployment model it's modular, and so ultimately sat on Docker. So these Docker are all backed up by mature DevOps pipelines. So even though we are EU hosted at the minute, we could just take this model and just deploy it anywhere. So we could even look at a self-hosted options in the future. So it's just a background in terms of module structure of these servers, these components that we have sat on physical servers in LeaseWeb. We then have our cloud-based compute resources, where Scaleway and Exascale. And the reason why we need media servers on demand, because we can't afford to have 100 media servers, sitting around dormant for 90% of the time. But so that was the choice there, and why we have on-demand media server scaling.
Okay. So, but I see that some of the media servers sit in LeaseWeb and some sit in Scaleway and Exascale then?
All these components all affect everything sits on physical servers and a rack and LeaseWeb, apart from the media servers, which we have to scale on demand. And it's effectively a cost choice. We want to support large events, but large events aren't run 24/7. So,
and I see at the end of the day that you've got here 3 different vendors, right? So that means 3 different sets of APIs for these vendors and 3 different business negotiations to every them. What are the challenges of handling that?
Well, LeaseWeb, we just rent a server effectively. When we need a server, we go and ask them, can I have a new server? And they're quick. Again, they can deliver servers in a day or so. So that's just a rolling contract we have with them. Scaleway and Exascale, they're very similar. APIs is very similar to AWS. So there's not really, as I mentioned before, it's not really much of a challenge that way. And they just charge us on a usage basis. So we would get an invoice at the end of every month, and we just pay it off.
Yeah. But yeah, I guess it is quite important to say also that the 2 elastic service providers operate in a similar way on a technical level. And then when it comes from a cost point of view, we actually have some cost advantages when it comes to Exascale, when we have, we've built a component for our own load testing internally. So we can we can do certain things with different vendors in different ways depending on the type of use case that we have, and gain some cost advantages there.
Okay.
But we primarily go with Scaleway now for the great majority of our scaling, simply because they're based in France and fit into, again, our European mindset best.
Okay. And I see, for example, that you've got all of your media running in the cloud-based compute resources. So Scaleway and Exascale, that's where the Janus media is. But then
We
the
do
turn
have
servers.
so we do have some media servers hosted in LeaseWeb on physical, because we do have to think about it takes a bit of time to bring up servers on demand. So we don't want to have customers or users hanging around waiting to see a stream in the room. So yeah.
Wait,
and then
so
the turn.
let's ask this. On a Sunday, let's say it's Sunday morning, would there be any servers running in Scaleway or Exascale, or it's just LeaseWeb because there is enough
It's
resources?
unless it will be probably we're running LeaseWeb unless we have a 1,000, 2,000 user event or some kind of concurrency issue.
Our
Then we
base
start
demand,
resources.
we always make sure that our base demand is covered by what's available on LeaseWeb. That's
okay, so
immediate access.
Okay, so what you've done is this: you've got the physical servers themselves, and you're saying something like, "This is the average use that we've seen in the last several months. We need to add more servers. We're going to add them into LeaseWeb so we get all of that capacity on physical servers, and then all of the spillover of peak is taken care of by cloud-based Scaleway and Exascale servers."
That's a good approximation, yes.
Okay. Let's go into the bits and pieces in there. Okay. I see that I guess the whole front end scaling is done using HA proxy.
Yeah.
For the scale out of the UI.
So the web HA proxy sits in front of the web app, the front end, and the dashboard component, and we just do round robin from the proxy. Yeah.
Okay. And then what do you use Redis in there for?
Sorry, I keep missing the start of your
what do you use Redis in there for?
We think it's just a database cache, and I think it just helps speed things up.
Okay. In terms
also,
of languages,
also it's used for like inter-process communication, because when you have a cluster, for example, several Laravel backends, they need to, for example, when you want to run a cron, they need to synchronize. For example, you want to cron only on one server, so they need some intermediate server to synchronize. So Redis has such primitives. So apart from caching, it's useful for like synchronizing between different clusters.
Okay. Now, in terms of languages, which programming languages do you use in your backend?
Okay, I can answer that. So we have this web app API, which is like the main API of the application. For example, you can create a room, you can configure it, you can retrieve recordings and so on. So this is written in PHP, and the more specific the Laravel framework, which is probably the most popular one. And the other like main part is the so-called data stream. So this is like based on Java and the Quarkus framework. It's a microservices framework, very popular in the past few years. So it's based on WebSockets for live room updates. For example, we have 100 people in the room. Somebody writes a chat message or starts a stream or do whatever, raises hand or whatever action you want. So all people need to be informed about it. And this is done through live updates, through WebSockets for efficiency. So Java on the data stream side, for live updates with WebSockets, and the RESTful APIs for Laravel and PHP.
Okay. Now, when I try to explain to developers how to build a WebRTC application, I usually say, there's these media servers here, turn servers there, and then there are the servers that are doing signaling in the application. Where would you say the application and signaling is in these slides? Like, is that the data stream or the web app API?
You mean the IaaS, the WebRTC signaling, or you mean
the signaling, just signaling, talking to the front end. There's an incoming call, outgoing call, user joined. Here's a new message that came in.
That's a data stream. Yeah, that's the WebSocket.
Okay. But that's the data socket. Where is the policies?
You mean what, WebRTC, IaaS, or what exactly?
No, policies. Who is the host of this session? What is he allowed to do, not allowed to do?
So on the backend side, so you can configure this both through the dashboard and through the API. If you want like more visual, you can use the so-called dashboard. So you can create some rooms. Each we have a roles framework, so you can configure as many roles custom as you want. But by default, we have moderator, speaker, and attendee. It's like Zoom style with the standard roles. And you can we have tokens. So you can create a JWT token, sign it with your developer key, and put the role inside the token. So when you give that link to the person, he joins as this role. So this is very similar to Daily and their API, let's say, token approach.
But then where would that go in this flow?
So in this flow,
data stream, or is that's where our signaling server, Peter, what we said, what we call our signaling server.
Like the so-called frontend. So first, the user makes a connection to Hub proxy to load the React frontend. When the React frontend loads, and establish a WebSocket connection to data stream. Data stream parses the token and knows, okay, a user joined with this row and to this room. So let's initialize the room, and so on. The journey begins.
Okay. So in a way, the brains of the system is the data stream.
Okay, to be exactly correct, first the API, the web API, which is the Laravel backend, receives the first request, and after that first request is received, it chooses a data stream. It load balances the data streams, chooses a data stream, passes the token to the front end, and then the front end connects to the selected data stream. So the API is like the initial brain, but then the brain switches to the data stream.
Okay. And what have you chosen to use for, and this is data stream is Java, web app is PHP, turn servers, I'm guessing is going to be Coturn.
Correct.
Okay, like everyone else. And then you've decided to use Janus media servers.
Yep.
Yes. Sir.
Why Janus?
So we've prepared a little journey for that. And what we're trying to show here is that a journey is not always a straight line. And we're trying to help other people here who may be asking themselves similar questions of where or how they should end up at their media servers. It's often for us, it was also a matter of timing. So, we've been around since 2003. So that's over, we're in our 21st year now. We did a lot of stuff on Flash originally, eventually started looking towards WebRTC in 2016. And at that time, the servers that were, or the open source media servers that were available, because we did not have it within our expertise or within our capabilities to build our own media server. The SFUs that were available were Corento and Janus and Jitsi maybe. And Corento at that time was, according to their marketing, at least in version 5 already, while Janus was really just beginning and Jitsi had just pushed its first release. I think Jitsi wasn't really on our radar anyways. So we were really quite, excited about Coreno. It had so many features. It offered an MCU. Our brains were just like, wow, loads of potential, loads of possibilities. And then eventually, after a lot of development time, we launched a private beta in 2017, which also still went well. And then Q2 2018 came around and we started to onboard, the first most brave customers onto our new WebRTC product. And then suddenly Conal had a lot of support tickets to deal with, and things started to go haywire because Corento just kept crashing on us over and over again. And we couldn't figure out why. In that time, Twilio had purchased Corento. So we also realized, okay, suddenly there's no dev team anymore. And we, all alarm bells went off and we needed to figure out a new server. We then tried Jitsi, because they had at that point been in their second stable release. It had just been pushed in around that time. So we were excited about that. Janus, if you look at the version numbers on this diagram, was still in version 0.2.2. So, just version numbers are not always a good indicator of where a particular product is. Jitsi, while again, looked great from a tech stack and is great from a tech stack, did not give us the flexibility we needed to build our own front end. We had our own vision of how we wanted to build this product. And had to discard that, and then we tried Janus, and we've been with Janus and happily running Janus in production for 5 years now, and it's been super stable. It's been the workhorse, running all of our streams. So big kudos. They've got a team sitting in Italy, in the beautiful city of Naples. Maybe a quick shout out. There's a Janus Con coming up, so anybody who's interested in that, please come. We would love to meet you there. And yeah, then we were also lucky. So then when we did the pivot to the WebRT, to this new product, we, Janus, you can see that towards the top right of the diagram, they launched version 1 finally in 2022, which had multi-stream. And we really needed multi-stream to be able to run sessions with 100 video users per room. That's what kind of our target. Zoom had showed the way here of how things need to be done in 2028 onwards. And we knew we wanted to build a product that could compete with that. And again, Janus has been incredible in that regard and helped us we needed.
Talking about versions, WebRTC came to version 1.0 only in 2021.
Yeah, that's the. Oh, really? According to my research, it was 2018. Then I made a mistake.
No. 2021. Okay. Until then, it was almost ready. Yes, we've defined it. Everyone already using it for many years now, so nobody cared.
Yeah.
I think the first time we met was actually in 2017 or something like that, when you showed me the first WebRTC current implementation that you had for Digital Samba.
That could be, yeah. Mm-hmm.
And what still resonates with me is that the UI was really, really compelling at the time. And I remember telling you that.
Thanks. I think it's better now.
Okay. Okay, so you picked Janus and you've stuck with it up until now and you're happy with it. Something that I missed on the protocol side, WebSockets means that you're doing stuff proprietary, right? Just to be sure.
Yeah, I mean, WebSockets, if we're going to use it, it's just for initializing the Janus sessions. Yeah, we're using our own WebSocket. We don't do like real communication, like chat messages through the Janus.
Okay, SIP or XMPP, it's your own.
Yeah, correct.
Okay. And when you look today at Janus, what would you say are the biggest advantages that it gives you today for the use cases that you're looking at?
Okay, so first, very important thing is scaling. And also Janus is pretty well built out of the box. So you just install it, you run it, and there is the so-called plugin modular architecture. So that they have the video room plugin, which you can directly put 100 people with cams on for multi-stream, and it just works out of the box. And if you want to scale for, let's say, more than 100 people in the room, you need to spread the streams to multiple servers. So if you have a webinar, let's say with a limited amount of publishers and probably 5,000 viewers, you would RTP forward the streams from the video room plugin to the streaming plugin in Janus. So you have, let's say, 10 boxes running the streaming plugin, and the streams from the video room plugin are forwarded to 10 different servers. So it's really easy and well documented to achieve. And that's one of the reasons we use Janus, because we can easily scale a webinar in that regard.
Okay. Have you made any modifications to the Janus code base itself?
That's a good question. So the GitHub community is really open and pretty responsive. So if you report an issue or you have some pull request, like Lorenz, which is the main developer of Janus, he's pretty responsive in the same day, and he's open to suggestions. And we made some contribution recently, a pull request. We needed a batch configuring request of streaming plugin, which means when you enter the room, let's say you have 50 tiles, you need to configure them in one request. So before our pull request, you need to execute, if you want to configure 50 streams, let's say move them to the lowest simulcast layer, you need to execute 50 requests, which obviously is not ideal. So we made this contribution, and it was merged by Lorenz a few months ago, and it works pretty well. So that's also a good thing about Janus, that it's pretty open to pull requests, suggestions, open discussions. Pretty cool.
Okay. Now we've talked on the client side very little. The client side, what you use there is React, right?
Correct.
Is that web or also native?
Currently, it's just the regular React framework. It's not React native.
Okay. What were the challenges that you had there that you needed to deal with in order to scale up the number of users, the video streams that show up?
Yep. So we have like two types, let's say, of meetings. First is the regular meeting with up to 100 people, which can have a cam on. So that's your regular, let's say, Google Meet type of meeting. And then we have the so-called webinar type of
So I
meeting
think
yeah.
it's these slides, right?
Yep, you can say that. Yep. So this is like how we scale regular type of meetings with up to 100 people in the room, and they all can have cam on. So that's the so-called Google, let's say, Meet type of meeting. So like the important thing here is, since you have so many like streams and they're also paged, the first like obvious optimization is not to subscribe to streams which are not on the screen. So if you have streams on the second page, you unsubscribe from the streams. And the other thing is obviously the simulcast thing, where like each user sends like different types of qualities, layers. That's what simulcast means. And like if somebody is not an active speaker or haven't like spoken for a while, like we switch them to the lowest simulcast layer, so it consumes only, let's say, 60 kilobits like per second instead of, let's say, 700. So, and when you do the math, you shouldn't go like more than 4 or 5 megabits per second, like for a room. Otherwise, people on poor connections could experience issues, and also CPU issues.
And today, let's say that today when you have a room, does that sit on a single Janus Media server, or is that distributed across different Janus Media servers?
Okay, so if we're talking about the 100 people, the all cams on, that sits on a single Janus server on the video room plugin, which is the core Janus media plugin.
Okay, and how do you do that? Do you allocate one Janus server per room, or do you squeeze multiple rooms into the same server?
We try to squeeze as much as possible based on the stats I have shown. So we're gathering live 3 types of stats. First is obviously the CPU and how much bandwidth, because each server cannot use more than, let's say, we're not going more than 80% of CPU is getting like tricky if we use more than 80. So we try not to go more than 80% of CPU, and the bandwidth obviously not more than 80 or 90. And also amount of users, like you shouldn't have, let's say, more than 300 or 500 users on the same server. It's just not performant. Like the CPU obviously increases with that usage, and if there is some glitch or something, too many users will be disconnected at the same time. And it just like for the streaming plugin, especially, like having more than 300 people is kind of maxing it out.
Do you count only users or also the number of rooms on a media server?
Actually, that's a good question. We count the amount of users mainly, but we treat like a room at least as a user. So there are, for example, you have breakout rooms and you're just initializing them. Each breakout room, since it doesn't have any users at the beginning, it will be a mistake to say, empty rooms, let's put them on the same server. So we're treating like a room at least as a user, yeah. So we don't like assign every. So we like avoid these pitfalls.
Okay. I see there's a question here. Can you talk a little on how you handle audio in a multi-room? You can open multiple cameras, up to 100 cameras. It's nice, but then you page them. So I'm going to show 4 at a time, 9 at a time, 16 at a time, whatever the number is, out of these 100 cameras that are allegedly in the room. What do you do about audio?
Yeah, about audio, first we have the DTX Opus enabled, so that helps when people are not speaking. It reduces, let's say, from 30 kilobits to up to 1 or 2 kilobits, so that helps with bandwidth, obviously. And currently we subscribe to every audio stream. We plan to optimize, if needed in the future, to subscribe, let's say, to last 7 active streams and so on, but that's a future thing. For now, we don't notice issues, but if it starts like producing issues, we'll subscribe only to last, say, 6 or 7 active streams. Which obviously, again, if somebody starts to speak again, will cause like some small blip because you were not subscribed to the new user, but that won't be like too noticeable.
But in the most part, you just don't do anything about that, and the assumption is that it's either going to die because of DTX, or that the user has muted his own microphone, as users usually do in large sessions.
Yeah, we currently rely on that because, as you're right, like if you have 100 people and at least 10 people will be making noise, it will be unbearable. So we have like global bulk muting. Yeah, so the host will mute all, and only if the person needs to speak, he'll speak. That's how generally are moderated such rooms. So currently we are relying on that. Yeah.
Exactly, we provide features for that as well, which is a good fix, allowing multi-mute or remote muting and things like that. So if somebody's noisy, you just switch them off.
Okay. And you said that you had 2 different types of meetings in terms of the architecture. What would be the second one then? This is for up to 100 people in a room.
Yep, correct. So this is the webinar type scaling where you can have max, let's say 15 or 30 publishers, and you can have currently up to 2,000 attendees. And we plan to scale that even further, but that's the first goalpost milestone, to have 2,000 users in a reliable way. So we are using the video room for publishing. There will be no more than, let's say, 15 to 30 publishers. And each of these streams is RTP forwarded to the Janus streaming plugin. As you can see, like each box can have, let's say, as a ballpark, 300 audience users. So if you have, let's say, 7 boxes, you can have like up to 2,000 attendees. So that's how we achieve webinar scale.
And then I'm assuming that in this case you are using dedicated servers for this, or again multiple rooms would be still in the same Janus media server in this case.
We're trying to currently reuse as much as possible. So like if there is free space, let's use it. But obviously, like huge webinars, they come like the users come for 5 or 10 minutes. So in most cases, they will have dedicated servers, but it's not part of our logic. It's just that what will happen in general, because we have some, let's say, low base usage, and suddenly all these people come, and like they'll most likely be taking the whole server when they come, or nearly the whole server.
So what you do is there is another one. So do you know which of these 2 scenarios happen ahead of time? So when I start a room, I probably need to say if that's up to 100 users room, or is that a live event, right?
Yeah, that's
so you need to make that decision.
Yeah, actually, that's a very good question. We thought about it, and currently you need to configure your room either for the API or for the dashboard. There is a max participants field. So if you put less than or equal to 100, it will be the first case. But if you put more than 100, if you put 110 or 500 or 2,000, that means you're going to have a webinar. In the future, we plan also to add templates, because it's quite useful to have different templates. For example, you select meeting, it will have 1 row. You select webinar, it could have 3 rows. So, but that's for the future, just some base templates. Currently, we rely on the max participants, so the user needs to configure. He wants more than 100, which will intend the webinar type of.
Okay, and then it becomes a webinar. How do you decide who joins the publisher rooms and who joins the audience?
Yeah, that's a good question. So we decided first based on the row. So the row has different kind of permissions. So if you have broadcast permissions, which in general is done like only by moderators and speakers. So if you have broadcast permissions, you'll be put on the video room. And also, like, there's the tricky case, moderator can enable like broadcast permissions to audience, obviously. So we have logic to check no more than 30 people can have that, because technically somebody could enable 2,000 permissions. So actually, the way we do it, we allow the permissions, but if you do not start the stream, you're not going to be moved. So you're going to be moved to the and actually we have 2 connections. So people would still be subscribing to the streaming plugin for receiver, but for publishing, so publishing goes to the video room, but subscription goes to the streaming plugin.
Okay, so in this case, what happens is all the publishers would go to the Janus video room
Correct.
to subscribe to the video room of the publishers, and everyone, including the publishers, will do. Wait, sorry. So all the publishers publish to the Janus video room,
Yep.
and everyone, including the publishers, are going to subscribe to one of the Janus streaming servers.
Depends actually. Initially, if you were a publisher, you will both publish and subscribe to the video room. But if you were like initially a streaming guy, like for an audience guy, you will be kept subscribed to the streaming plugin to avoid moving, because if you move streams, there will be a glitch. It becomes very tricky to move people around media servers. You need to establish two connections and destroy the pre. It's not good.
Yep. Okay. Interesting. And how do you keep the balance or the load balancing between these Janus streaming servers?
Yep. So about load balancing, we have, like, based on the stats we showed in the previous slide, so we gather them from all servers. So we're trying basically not to have more than 300 people. CPU doesn't go more than 80%, and bandwidth doesn't go more than 80 or 90%. So what we are doing is we find the server which is least busy. So the question is, what's the least busy server, because we have many metrics. So we're basically selecting each server which has the lowest metric from the three. So no matter if it's CPU, bandwidth, or users, because you can have theoretically a CPU of 10%, but maybe your bandwidth is at 8, or and they're like different. They're not very likely these cases, but they are possible. So based on these metrics, we are selecting the lowest. Let's say the lowest.
The lowest maximum.
Yeah, the lowest maximum, and also it's like filling a bottle up to a point. So we are filling the server, but let's say up to 100 users, and then when we try to scale to another one, we're trying to avoid all this thing. Let's fill the bottle up to the point where it starts to pour out and then go. No, we fill it, let's say, up to half, then we go to next, and only after have a decent amount of servers we can start filling up to the top. But we're trying to avoid like this filling to the top, because it can easily backfire.
Okay. And at what point do you start opening machines in the cloud?
Yep. So we have like a pool of servers. First, we have the base servers in LizWeb. So if we have this logic, if you don't have more than one server available, let's say 3, then we start new cloud servers. So we're trying like to preemptively not wait like 99% to be filled. We're basically trying to have like 2 servers on our like 2 free servers. Yeah.
Okay.
And then when these new servers which we started, when we get filled again, we start new. And there's like some edge case, because like starting a server in the cloud isn't instantaneous, as you know, so it takes up to around 30 seconds in AWS and also in Exascale. In Scale, it's like pretty standard that it takes around 30-40 seconds, sometimes even a minute, because they're like hypervisors, that there's no guarantee how fast it starts. And if you have, like, say, many people waiting, because we have lobby, let's say there can be 2,000 people waiting in the lobby. So the question is, do we wait for these people to enter the room, or we start preemptively the server? So we have this optimization. So if you have 2,000 people waiting in the lobby, we start 7 servers before the meeting starts. Because the other option is, let's say the lobby is released. We don't have any servers, so let's make the people wait, let's say 5 minutes. This won't work well. So if we see that basically people which are waiting in the lobby, we treat them as live users. So we include them in the count of the load balancing calculations, and we preemptively start servers, so it's more fluid. Yeah.
Wait, if they're in the lobby, I guess there are 2 types of decisions that you're making. The first one is, where do I put that person once he goes from the lobby into the meeting?
Correct.
Right? Only then you can say, well, he's going to Janus Media Server, in this case, N, because N has a CPU of 30, and it looks like the freest one.
Yep.
And then the other one is to say, let's see how many users we have in total, right? And can we serve this total number of users with the number of Janus Media servers that we have?
Yeah, correct. It's like a simple calculations. You say you hard code a number. Let's say each server can handle 300 users. So if you have 2,000 people waiting, divided by 300, we say we need 7 servers.
Okay, and if you have less than 7, you're simply going to add more servers because at some point, these people that are waiting in the waiting rooms in the lobby are going to be on a media server, let's say
Correct.
90% of the time. So it's like saying we need to count them in so we can bring the machines ahead of time.
Correct.
Now here's a nagging problem. This is probably more for you as well, Conal, because you've been too quiet. So now I've got all of my machines. We had the peak. Many of the users are in the cloud. We don't need so many machines at the moment, but all of the users are spread all over the place on different types of machines. What happens now when machines go to CPU of 30% on average across all of them? And there are like 5 or 10 machines in the cloud that you can say, well, I don't need them, but there are people here.
Yeah, this is ultimately Peter's code, so I think it's better he answers it. I wish I could take some heat off him, but I think it's better Peter
So your
answers
question is if you have
Okay.
lobby people, or what?
How do you scale down?
Correct. So as long as there are people, so we compare the amount of people on the platform, including the lobby, to the amount of servers we have, and we try to keep at most 2 servers free. So if you have, let's say, 5 servers, we have 5 servers live, and all people can be handled by 2 servers. That means we just stop them down. We stop.
But the people that you have on the servers, how do you stop a server if it's active? Like if there are users on that server at the moment?
That's a very good question. So currently we are waiting for them to for all people to be gone. Yeah. In the future we can implement let's say there are 1 or 2 people, we can disconnect them. We need to it won't be ideal experience, but in the end we have to decide between if somebody goes to a room and goes to sleep, do we wait him to wake up 8 hours and consume a lot of money, or we just reconnect them to another server? Yeah, that could be done in the future. If there are, let's say, less than 5 people on the servers, we reconnect them. It's not ideal, but there needs to be a compromise. We cannot, let's say, if we start 30 servers, for a webinar, and here is 1 person, here is another, we cannot, this is consuming, let's say, 60 euros per hour. It's just not. Let's say, yeah.
So today you'll simply shut down servers if you feel like you don't need them and the usage is low.
We never shut down servers where there are users on there. We just
Okay.
It's not a big problem. Let's put it that way right now.
Okay.
And there is other thing. Yeah, we're trying also to fill services up to a point, like I said, up to 100. So we're trying not to spread too many people. So the moment you spread, let's say, too many. Sorry, give me a second. Okay, so basically I was trying to say, so we shouldn't give to people, spread them too much on many servers if they're not full. So if one server is up to 5, has 5 people assigned, it doesn't make sense to assign people to another server. So if you have 5 people here and 5 people there, it's they're going to be alive too much. So we're trying to fill server up to 100 people, and then we start going to the other server. So it has some sort of what I said, filling the bottle up to a point, let's say up to a third.
Okay. So first of all, I'd like to thank you. I've learned a bit about you and what you're doing and the new back end of stuff and the technical things. You're one of these vendors that are saying, well, if you're not using Tula programmable video anymore because they're sunsetting their service, come to us. If you want to say something about that before we conclude, Robert.
Yes, please. Thank you so much for that segue. So we also thank you very much for the opportunity to be on your show. We actually really enjoyed the first minute with 100 MS. I thought that was really great. I appreciate you grilling us. Your questions are excellent. So thank you for that. we are obviously, Twilio sunsetting took not just us by surprise, but also a lot of customers. We want to help customers who are interested in Digital Samba. We offer a 50% discount over the first year of moving to Digital Samba. We understand that this is a painful period for everybody. Hopefully we can help some companies learn about how easy pre-built is. The transition does not have to be painful. Working with pre-built software is a lot easier than developing everything yourselves. So that's our pitch. Come to us, talk to us. We'll show you what we can do. We're happy to give you a demo. As you can see, we're approachable. So thanks a lot.
Okay. Thank you all, and thank you for being here.
Yeah. Thanks.
Thank you.
Bye.
Bye.
Cheers. Bye-bye.